Sec 3 NA Mathematics, Chapter 5, Coordinates Geometry, Part 1. Now, in this part of today's lesson, we'll be looking more at revising the Sec 2 concepts and Sec 1 concepts on gradient of a line segment. And then we'll learn a new concept on length of a line segment. Coordinate geometry. Now consider the following coordinate system where you have the x-axis over here, the horizontal x-axis, and we have a vertical y-axis. If I were to have a line segment with 2 points, taking this point to be x1, y1, and this point over here to be x2, y2, okay, we can mark the points of this line. Okay, if I were to find the gradient of a straight line, the gradient of the straight line is a measure of the slope of this line. It is the ratio of the vertical distance to the horizontal distance. Now, which means the vertical distance is actually the rise over the horizontal distance, which is the run. Now, what is the rise in this case? If we to look at our diagram over here, this actually forms a right angle triangle. So when it forms a right angle triangle, the rise will be given by from this to this point, which means the difference between y2 and y1, which gives me y2 minus y1. And then I have my run, which is the distance between x1 and x2. So it will be x2 minus x1. So in other words, gradient is given by the formula y2 minus y1 over x2 minus x1. Now, what are the different types of gradients? So actually we had 3 different cases, okay, for the following cases. Number 1, if we were to have a slanted line. So something with a slanted line will look like this. If I have a slanted line, it will have a gradient, and the gradient will be given by y2 minus y1 over x2 minus x1. It can be found using 2 points, any 2 points, x1, y1, x2, y2. It can be an upward sloping line. In this case, if it's an upward sloping line, the gradient is positive. Or it can also be a downward sloping line. Okay, that means in this case, the gradient will be a negative value. Now, these 2 cases are quite commonly seen. But now we also have another case of horizontal lines. Now, if I were to look at a horizontal line, it looks something like this. Compare it with my axis. This horizontal line, I'm walking flat on the ground. When I'm walking flat on the ground, is there any gradient? No. So for a case of horizontal line, gradient is 0. There's no gradient. But then this kind of line have a special equation. The equation of the line is always, this line always cuts the y-axis at the number, let's say a. So for this type of equation, it always comes in the form y equals to a. Notice there is no x in this equation. So for example, if I were to give you a line that is cutting the y-axis at the number -3, then this equation will be y equals to -3. Notice that there's no x, okay, because in this case, there's no gradient at all. Now, the third case, if I were to have vertical lines. So vertical lines are parallel to my y-axis, but it cuts the x-axis at a particular number. Now for this kind of thing, can you imagine how am I going to walk on this ground? It's almost impossible, right, to be walking on the ground or climbing up. Okay, so in this case, you have a particular gradient. Now normally students can still calculate. Let's say I have 2 points over here, and I call this maybe the point. This all cuts at the same number. Maybe let's say this is 5 and this number is 10. This number is -5. So my gradient over here, this is y, x is 5, y is 10, x is -5, x is still 5, but y is -5. Now what will I have for my rise? That is a vertical distance of 10 minus -5, which gives me 15. But what about the run? The x-coordinate is 5 minus the x-coordinate is 5. Can I have a number that divides by 0? No. So in this case, the gradient actually, we do not even need to count this gradient at all. We know that this gradient, anything divided by 0, will have the number infinity, the number 8 that fell down. So for this kind of line, there is no gradient at all. Okay, it's just a infinity gradient. But this kind of line have a special equation. This line doesn't cut the y-axis, it only cuts the x-axis. So in this case, it will only have the equation x equals to a particular number. So for example, if I were to give you something like that, and this is 20, this equation here will be x equals to 20. Notice that there's no y at all. Now, what are the difference between these three cases? Case 1 is a slanted line. It cuts both the x and y axes. So my equation for this kind of line is y equals to mx plus c, because it cuts the y-axis and the x-axis. For the second case is a horizontal line. There is no gradient at all, and the equation is just y equals to something. For the third case, when I have a vertical line, there is a gradient of infinity, and the equation will only have x equals to something because it only cuts the x-axis. Now take a little bit of time to write down the following information and try to remember them a little bit. Okay, up next we will move on to the length of a line segment. So we're going to move on to length of line segment, but before we move on to length of line segment, let's come back to our diagram over here. Now we notice that this was already mentioned to be a right angle triangle, am I right? So if I know this length over here and I know this length over here, how do I find the length over at this side? Now this is a right angle triangle, that means this will be the hypotenuse. If I have a right angle triangle, what do I use? I can use the Pythagoras theorem. So if I want to find the Pythagoras by the Pythagoras theorem says the hypotenuse square is equals to side 1 square plus side 2 square. In this case, if I want to find the length of this line segment, this is actually the hypotenuse, right? And what is the other two side square? Well, this side is given by x2 minus x1 holding square plus y2 minus y1, this one over here, holding square. That means our length will become, for the hypotenuse, or rather the length of the line segment, I'm going to use the word length of line segment, which is the length, will now be taking the square root of something square plus something square, just like the Pythagoras theorem, but the numbers inside is x2 minus x1, y2 minus y1. So therefore, we have gotten the formula for calculating length between 2 points. Take a second, copy this down into your notes. Moving on, let us try to use this formula to solve our answers. So question over here says, ask you to find the length of a line segment. If you are given a point A is x1, y1, and a point B is x2, y2, the length of this line segment is given by square root something square plus something square, which is y2 minus y1 square, x2 minus x1 square. It doesn't matter which position you write first, okay, as long as you match the x2 with x1, y2 with y1. Now we should put these two concepts into use. Let us recall again. Gradient is given by y2 minus y1 over x2 minus x1, and the length of line segment is given by square root something square plus something square, and it will be y2 minus y1, x2 minus x1. Okay, so let us begin. The line AB is shown and we have two particular points. Find the gradient of AB. Are you able to get the answer? Part 1, gradient equals to y2 minus y1. That will give you 2 minus negative 3. Please be careful about the working. There's a negative number, put a bracket. And 5 minus negative 5. What answer do you get? The answer is half. Next one, part 2. Find the length of the line segment AB. So AB in this case will be square root of something square plus something square. And in between we have y2 minus y1, 2 minus negative 3. Please remember to put brackets for your negative numbers, because your calculator may show a different number if you do not put a bracket. Then x2 minus x1. And we'll be able to get the answer. To find sig fig, 11.180, then round off to 11.2 units, 3SF. Now, up next, we shall practice a little bit more of the concepts available. So I'm going to leave these two questions for you to do on your own later after you watch the video. So this will be your practices, and then I'll go through them in class the next lesson. Alright, then now I'm moving on to the next page with a slightly harder question, but still doable. So let's carry on. Next page over here. Now in this practice, the question asks you to find the gradient of a straight line passing through these 2 points. Now what do we know? We know that these have 2 points. I have x1, y1, x2, y2. So if I were to find a gradient, that means, but this is all in algebra, right? So it doesn't matter. We're still going to use our concept anyway, and we should be able to get to the answer. So using this concept, gradient is y2 minus y1. That means 14a minus y1 is 8a over x2, which is 5a, minus x1, which is 2a. Simplifying, we get 14 minus 8 to be 6a. 5 minus 2 is 3a. And what do you notice about a and a? They can cancel away. And then 6 divided by 3 will give you the number 2. So therefore, the gradient of this line will be 2. Example number 3. If the gradient between 2 points is 3, how do we find the gradient between 2 points? We have x1, y1, x2, y2. Now gradient is 3, that means the gradient equals to 3. But how do we find the gradient? We need to form an equation first. So it's equals to 3, but the gradient tells me is y2, which is the number 8, minus y1, 2, over x2, a minus x1, which is 3. Now what do you notice here? I have a fraction over here and there is a fraction over here. So let's try to simplify. What is 8 minus 2? 6, right? So 6 over a minus 3 is equals to 3 over 1. What can we do? Yes, we can cross multiply. So if we were to cross multiply, I will have the equal sign in the center. This will be 3 times of a minus 3, and this will be 6. So expanding our equation and expression, I will get 3a minus 9. Now I'm going to keep 3a over here. This is 6. Negative 9 will migrate over and it will become positive 9. And that will give me the number 15 is equals to 3a. If 15 is equals to 3a, then a will be divided by 3 to give me the number 5. Have you gotten the answer? Okay, last part of the practice for today, and I'll leave you to do the rest of the questions required. I'm going to do one more example for you. Now in part A, if the gradient between these 2 points, okay, I give it to be x1, y1, x2, y2, is the number negative 2. So they tell me that gradient is negative 2. Gradient is given by y2 minus y1, which is b minus negative 1 over x2, which is the number negative 1 minus x1 for this gradient is equals to negative 2. Before that, let us simplify. I have b minus negative 1. That means it become b plus 1 over minus 1 minus 4. That's negative 5. Now I can cross multiply my equation. B plus 1 will be equals to 10. And b will be equals to 10 minus 1, 9. Have you gotten the answer? So if you have gotten the answer, I'm going to leave you to do question B on your own. And then we'll get back to class to check the answers in the next lesson. Now we have done a few practices on gradient already. Now let's move on to the next concept on our, practice the concept on our distance between the 2 points. I shall just do one more example over here for A, and I'll leave you to do for B on your own. Now, given that the distance between A is and B is 5 units, the distance, okay, between these two. But let us try to recall how do we find the distance between 2 points, or rather the length between the 2 points. So in this case, since they want distance, instead of length, we will use the word distance. So the distance between 2 points is given by the Pythagoras theorem, something square plus something square, and the formula inside will be y2 minus y1, x2 minus x1. Okay, let's try to use this formula and plug in some numbers. So in example A, I have x1, y1, x2, y2. Now it tells me that the distance something square plus something square is equals to now 5 units. So first thing I'm going to do, I'm going to plug in the y values. y2 is p minus y1, which is 1. x2 is 2 minus negative 2. Okay, so now before we do anything, we notice that there's a square root here. How can we get rid of square root? The opposite of square root is to square both sides. So if I will square both sides, I'll get the number 5 squared to be 25. And this number here, this is what number now? There will be no more square root on this side. 2 minus negative 2 will give you 4. That will be 4 square plus p minus 1 whole thing square. 4 square is the number 16. But there are some of you who will make careless mistakes down here. P minus 1 whole thing square is actually p minus 1 times p minus 1. We repeat it the same, exactly the same. Do not change the sign. So now we're going to do some expansion, and you will expect a quadratic equation. I have p times p square minus p plus 1. But if I want to solve a quadratic equation, it has to be equals to, this needs to be equals to 0. What can I do to the number 25? Well, you have to shift over to negative 25 over here. And now we're going to solve this quadratic equation. Let us rearrange. Remember, we have to rearrange the terms into p square, p, so x square, x and number. So in this case, it will be p square, p, this will be negative 2p, and number. What's the number over here? I have 16 plus 1 minus 25 to give me the number negative 8 equals to 0. Question say find the possible values of p. So we'll try to do a factorization. P times p square. What times what gives you 8? 4 times 2 gives you 8. You have 4p, 2p. I want a negative 2p, so the negative sign should go to the larger number. Then this will be plus. So I have two brackets over here. The answer for this part is p minus 4, p plus 2 equals to 0. Therefore, p equals to 4 or p equals to negative 2. Have you gotten the answers? So now, you should try part B. And I'll go through this in class, the next lesson. We'll stop here for the day and leave you to do the work on your own. See ya!